Hydraulic System Servo. We are going to discuss the twin servo used to control the opening and closing of the IGV and VSV blades. This is a view from the right-hand underside of the turbine where the hydraulic pump and twin servos are located. The twin servo is mounted directly on the pump, and the hydraulic fluid passes to and from the pump through internal drillings in both pump and servo. Core principle of a servo control. The system operates in a closed-loop configuration. The CPU compares desired position of the IGV or VSV with the position feedback signal, then adjusts a servo valve to direct hydraulic fluid accordingly. The shuttle valve in purple is positioned by the control to block the flow of hydraulic fluid to the actuator, or it sends the fluid to the opening or closing side of the actuator to extend or contract it. The shuttle valve is positioned by the controller through the use of a torque motor. We are now going to take a detailed look at how the torque motor works. The purpose of the torque motor is to modify the control pressure C1 and C2, to position the spool valve in purple. The difference in pressure between C1 and C2 will decide which end of the actuator will be supplied with pressurized oil. The diagram shows the torque motor in the neutral mid position. When the control signal from the turbine control to the servo is 110 mA, the flapper plate in red is positioned in the mid position, and the control pressures C1 and C2 are equal on both sides. With the torque motor in the null middle position, the pressures C1 and C2 are equal. The spool valve is in its neutral position, covering the ports to the actuator head and rod. Pressure from the pump comes in here, but the exit is blocked by the spool valve. The pressure can't go to the head or rod end of the actuator. The pressure C1 and C2 are equal, therefore the pressure either end of the spool valve are equal, so the spool valve will not move. The oil not being used will go straight back to the pump to be recycled. Let's look at an example where the IGV actuator is at 44% open, and the control wants to move them to 46%. That is 2% more open. As you extend the actuator, you move the blades to a more open position. If you want to extend the actuator, you need to send the pressurized oil to the head side of the actuator. The turbine control system output signal to the IGV actuator is decreased from 110 mA to a lower value, let's say 105 mA for example. This causes the flapper plate to move closer to orifice controlling C2 pressure, causing the pressure to increase. The opposite happens to the pressure of C1, it decreases as the orifice flow has less of a restriction. Because now C2 pressure is greater than C1 pressure, the spool valve moves down. This movement of the spool valve uncovers the supply to the head side of the actuator, so the pressure extends the actuator. The rod end of the actuator is now connected to the return side, and the oil is forced by the piston out the yellow line towards the pump suction, to be recycled again. Once the actuator position feedback indicates that the actuator is at 46 degrees open, the control signal is returned to 110 mA, and the flapper plate will be positioned by the torque motor to the null position. This will equalize the pressures C1 and C2. Therefore the spool valve will return to its neutral position, blocking the oil from going to the actuator. Increasing the control signal to a value greater than 110 mA has the opposite effect, retracting the actuator.